The question is, a pendulum is hung from the roof of a sufficiently high building and is moving freely to and fro like a simple harmonic oscillator. The acceleration of the bob of pendulum is 20 meter per second square at a distance of 5 meter from the mean position. So it's asking what will be the time period of oscillation. So now from the question we can say that, we can find that pendulum is displaced, with a small angle so that it performs a harmonic oscillation. So the equation of motion for harmonic oscillation, we know that it can be given by A equal to W square x. Here this is angular, and now this following information is given in the question. This one, that A is 20 meter, 20, array is nothing but the acceleration. So this is 20 meter per second square. So now we also know that our x is, that is nothing but the displacement from the mean position. It is also given 5 meter. So now we can use the formula. We will substitute these value in this equation. So what we will get, 20, in place of A we will put 20 equal to this angular square 5, x is a 5. So from here we can find out W square will be 4 and W will be our 2 per second. 2 per second. So as we got the value of angular frequency, now let us use the formula W equal to 2 pi by T, because we need to find the time period of the oscillation. So now in place of W we can write, because we have find the angular frequency, it is 2 per second equal to 2 pi by T, 2 pi by T. So it will be, T will be equal to, solving we will get T equal to pi second. So this is our answer. So this option is the correct. Thank you.